Unit 9 in the semester review packet. Please keep in mind you should not be copying from this video. Alright, you should be using this video for problems where you're not sure if you're right, or if you've already started working, you got some writing down, but you're not sure where to go next. Alright, get that hint, pause it, and then finish the problem. Alright, correct your mistakes. Alright, but do not copy straight from the video. Alright, example 1. So in Unit 9 we learned about graphing parabolas. Alright, we learned how to do them by hand and by a calculator, so I'm going to be showing you both here as we go. Alright, looking at the first problem, alright, we're asked to identify different parts of the graph. So just quite simply, do you understand what each piece is? So the vertex refers to the tip of the graph, whether it's the top or the bottom, which would be right down here. This is your vertex. Alright, so it's over 1, down 1, 2, 3, 4. So my vertex is at 1, -4. And then you're asked if this is a max or a min. Okay, remember that's based on position of the graph. This is a parabola that opens up, which makes that a minimum value. Okay, the axis of symmetry is the invisible line that cuts our parabola in half. It runs right through the vertex. Okay, it's a vertical line, therefore it has an equation of x equals. Alright, and in this case it's passing through 1, so it's x equals 1. Remember, we said when we did this that these two things are related. They're the same thing. The x value of the vertex and the axis of symmetry. Alright? The zeros are when your parabola cross the x-intercept, or the x-axis. They're also known as the x-intercepts. Okay, and in this case you would have 1, 2, 3, 3, 0, and -1, 0. Alright, so again, we call those the zeros. The x-intercept, we also refer to those as roots. Alright, and then our y-intercept is where we cross the y-axis at, which is right here. So down 1, 2, 3. So that's 0, -3. Alright, so those are the different parts of a parabola. Let's go ahead now and take a look at finding the vertex. We're going to, like I said before, we're going to do one by hand, and we're going to do one using our calculator. So when we do it by hand, we use a very simple formula, which is the opposite of b over 2a. Alright, this is a, this is b, and that's c. So I would do the opposite of b, which is positive 12, so the opposite would be negative, all over 2 times a, and that would be -12 over -6, which will simplify to a positive 2. Okay, that's the x value of my vertex. Alright, so my vertex is going to be 2 comma something that I have to figure out. And the way I figured that out is I plug my 2 in for x here and here, alright, and simplify it down. So it's going to look something like this. -3, 2 squared plus 12 times 2 minus 20. Alright, 2 squared is 4. 4 times -3 is -12. Plus 24 minus 20. That's going to be right here, positive 12. Minus 20 would get me to -8. So my vertex is 2 and -8. That's doing it by hand. Again, using opposite of b over 2a. That's how you find the axis of symmetry and the x value of the vertex. The other way you learned was by using your graphing calculator. I hit the wrong button. There it is. Alright, and the way we did that was we went into our y equals. Alright, and we typed our equation in. So in this case, it's 2x squared plus 4x minus 3. We did a graph on that. Uh-oh, I got to turn off my stat plots. So let me go into my y equals. I'm going to press 4 to turn off all my stats. I'm going to reset my window for standard. I'm going to zoom standard here. And now I'll get my graph. Okay, so that was a good review of turning on and off stat plots for when you have to do that in Unit 8B. Alright, so here's my graph. And the reason why I do this is because if I want to locate the vertex, I have to know if it's a max or a min. So by looking at it this way, I know it's at the bottom. That makes it a min. So now I'm going to calculate that by hitting second trace. And I want to calculate a minimum value, so that's my third choice. And I have to set up a left and a right bound. The way I do that is I go to what is clearly the left of the vertex, And then I go to where I'm clearly to the right of the vertex. It's going to ask me to guess. We're not worried too much about that. I just go ahead and hit it, and I end up with my vertex being, oh, where'd it go? Oh, -1, -5. It's going to disappear when I go to right. Okay, so there's two ways of doing that same exact problem. All right, so let's move on now to 4 and 5. Again, we could choose to do it by hand or by graph and calculator. All right, what we need to do is find the vertex, then use the vertex to create a table to find other values. All right, so I'm going to take this first one, and since I have my calculator ready, I'm going to do the first one using my calculator. All right, so let me go ahead and slide this over here. All right, there we go. So I'm going to enter my function in, which is going to be -2 x squared plus 8x minus 5. Okay, again, I'm going to look at that graph first, determine if I have a max or a min, and you'll notice in this case, right up here, all right, I have a max value. So I'm going to go ahead and second trace. I'm going to calculate the max. And I'm going to go clearly to the left, hit enter. I'm going to go clearly to the right and hit enter. Don't worry about the guess. We end up with 2, 3 as my vertex. Alright, so what I'm going to do next is I'm going to create a table. Alright, where 2, 3 is in the middle. I'm going to find the values of 1 and 0. So it goes 0, 1, 2, 3, and 4. I always want my vertex to be the middle point. So I'm going to go back to here. I'm going to go second table. I'm going to arrow until I get my vertex in the picture. Almost there. Alright, there it is. So remember, when we look at our table, we should see some symmetry to it. Alright, especially if we have integer values. So now I have 1, 1, and my other one was -5 and -5. So I have my points. I'm going to use that to create my graph now. So I go over 2, up 3, there's my vertex. It has an axis of symmetry going through it. That's my reflecting point. Alright, then I do my 1, 1, and its mirror. And then I do my 0, -5, 1, 2, 3, 4, 5, and its mirrored point over here. And there is my parabola. Alright, try to make that as smooth as you can. There you go. Okay. Doing it by hand, again, we could do the opposite of b over 2a. So that would be opposite of b over 2a. That's -2 over 2, which is -1. That means my vertex is -1. And then I could plug in to find my y value. So I would have -1 squared plus 2 times -1 plus 3. So that's 1 minus 2 plus 3. -1 plus 3 is 2. And then instead of creating a table, the other thing we said is we could use the intercept. So in this case, the y-intercept is 0, 3, because that's the c value. So I would do my vertex first, -1, 2. I would plot my axis of symmetry in there. Then I would graph my y-intercept, 0, 3. Mirror it over the dotted line. And create my graph. So there's two ways of doing it. Alright. Both, I think, if you know what you're doing, don't take that much of time to do. Alright. Moving on. So the last thing we have to do is find zeros. Finding zeros is another way of saying solve the equation. Okay. So there's a whole bunch of different ways we could solve. We could do the quadratic formula. Alright. We could do factoring, possibly inverse operations, or we could use our calculator. I'm going to review on this one factoring because it's factorable. We would do x minus 4, x plus 2, which means my zeros would be 4 and -2. Okay, that's again a review of factoring. Again, you can use quadratic formula if you want as well. The other way I'm going to show you is on your calculator. All right. So we have a ball thrown upwards at 15 at a height from a height of 15. I guess there should be a meter measurement there, so 15 feet, with an initial upward velocity of 5 feet per second. We want to use this formula to see how long it will take for the ball to hit the ground. That's the same thing as saying what's the zero, because when it hits the ground, so here's the ball, all right, it's 15 feet in the air, it gets thrown, and it hits the ground. That's the x-intercept, okay, which is the same as the zeros. All right, so my function is going to look like this. I have negative 16t squared. My initial velocity is 5, and my starting height is 15. So when I go to use my calculator, remember, this is y, and these are my x's, okay, in my calculator. So I'm going to do y equals, let me go ahead and clear this out. I have negative 16x squared plus 5x plus 15. Alright, let's go ahead and take a look at that graph. You'll notice it's off of my chart, so what I want to do is a zoom fit, alright, which is off of my screen right now, but when you arrow down, you'll find it. Zoom fit is going to be 0, or 10 if you're counting this way, so but press the 0 button. It's going to fit our graph in. Okay. Ooh, that's pretty ugly. May actually be better to go back to the standard window for what we're going to do. Alright. So let's go back to the standard window, because really I just got to find the zeros. Alright, and more specifically, because this is a word problem, I only need to find the positive 0. So here's how I find the zeros. Alright, again, I go into my calculator feature, so second trace, and now I need to calculate a 0, so that's the second choice. Alright, I need to establish a left boundary, so I need to be above, because as I'm coming down this way, I'm starting to the left and working my way to the right. So there's my left bound. I'm going to arrow down. There's my right bound. And I hit enter, and I end up with an answer of 1.1. Let me check my rounding here. The 7 tells the 3 to become a 4. 1.1 comma, sorry, 1.14 comma 0. And that means it takes 1.14 seconds to hit the ground. Remember, we didn't use the negative value because it doesn't make sense in terms of how long that ball's in the air. Alright, we can't have negative time, so I didn't even bother finding it that way. Alright, but you can always find your intercepts that way by going back and doing a left and a right bound on that one and get that negative answer in case you have a generic problem like number 6. Alright, that's it for Unit 9. Alright, good luck on your final.